Hi there, this is Ron Wade with IDT with another technical tidbit. Today we're going to talk about a properly terminated clock line. And what we have here is a drawing of a generic clock. We have a single-ended buffer here with the output impedance represented by Z0. We have a series termination resistor, and we have a 50 ohm transmission line with the load represented by this capacitor at the end. All of our measurement points are going to be at the load right here. And so really what we want to do is we want to have the sum of the output impedance of the driver and the series resistor exactly equal to the impedance of the transmission line. When we do that, we have a perfectly nice clock here which comes up, rounds off, goes down, and goes back up again. And that's the case for Z0 plus RS, the series resistor, equals 50 ohms. And you can see it's a great clock. There's no overshoot, there's no undershoot. The tops and the bottoms are flat. And ignore the duty cycle because that's my handwriting. Now what happens if the output impedance plus the series resistor are less than 50 ohms? So when you see your clock and you have ringing on the top and undershoot on the bottom, where it's called overshoot and undershoot, that means that this is less than 50 ohms, and to correct that you would need to increase the size of the series resistor. The other case is when the output impedance of the driver and the series resistor, the sum of those, is greater than 50 ohms. That's when you'll see a step on the rising edge and the falling edge of the clock. Here you can see this little step that I've drawn, which indicates that this impedance is too high for the transmission line, and the impedance here, again, it's too high for the transmission line, and you'll get this step. To fix this, you'll need to make the resistor a little bit smaller. So that's the technical tidbit for today, how to look at your transmission lines and see if they're perfectly terminated or not.